Hi, welcome to Workbook 17. You are maybe catching up, or if you're watching this, I'm sure you're catching up by now, especially if it is after April 16th, 2021. Anyway, so you're catching up, and please pardon the boxes in the background. Everything is going to be fine. We are going to be talking about Workbook 17, which includes the workbooks and the checkpoint for 17. If you are watching this because you are behind and maybe your workbooks are excused, please make sure you watch this part too to make sure that you understand it for the checkpoint. So we have inscribed angles and intercepted arcs. So first of all, we know that if we have a circle right here, in fact, let me see. Yeah, if we have a circle like this one, that's like on the outside here, that we have inside angle ACB is a central angle. We know that. But then we have the part that it intercepts right there. That is called an intercepted arc. So if it's part of a circumference, it is called an intercepted arc. Then we have inscribed angles. What an inscribed angle is, it still has that same arc, but instead of having the vertex be at the center of the circle, the vertex is on the circle. It's another point on the outside part, like on that circle. That is called an inscribed angle. So whether the circle is, the angle is up here, or if we pull it over to the side like that, it's the same arc, which means that those angles are the same. So if two arcs have two inscribed angles intercept the same arc, they're going to have the same angle measure. One thing that you need to know about that, though, is that angle measure is half of the angle, the arc, the measure of the arc. So like if this was 50, this would be 25. If this was 60, that would be 30. So it's half of that. Or the other way around. If we knew that this angle right here was 15, then this would be 30. Or if this was 45, then this angle would be 90. It's not in this picture, but we're going to go with it. So those are the main things that you need to know. One is that the inscribed angles intercepting the same arc would have the same measure. The next thing is that the inscribed angle is half the measure of the arc length, and the other way around, the arc length is twice the measure of the inscribed angle. Third thing is if you have an inscribed angle that intercepts the semicircle or half of the circle, then this angle at B has to be 90 degrees. So no matter where it is on here, if you move to B all the way around here, that measure of the angle is always going to be 90 degrees. Okay, so we are going to do the workbook problems, and so please watch and follow along. So we have a central angle that is at P, and then an inscribed angle that is at Q. And they make it fancy saying angle OPR and angle OQR. If we were to talk about the relationship between those, well, that central angle and the arc are the same, but that inscribed angle is half of that. So half of 70, half of OPR would be 35. Oops, 35. So then we have this one, where again, we have that central angle. It's the same as the arc, and then this inscribed angle would be half of that. So let's see, angle EQD would be half of 104. So half of 104 would be 52 degrees. And then we have this, that is a semicircle right there, right? Because it goes through the diameter. And if that one's 30, we know that that has to be 90. So we know also that the angles all add up to 180 inside of a triangle. The sum of the angles inside of a triangle equal 180. So 30 plus 90 leaves us with 120, which means 180 minus 120 leaves us with 60. EFJ must be 60 degrees. Or another way of looking at it, these two angles at the bottom must add up to 90. So 30 plus 60 equals 90. So that was 17.1. Okay, 17.2 is coming up here. And then we have the checkpoint. And that will be it. So we talked about inscribed angles. Now we're talking about inscribed quadrilaterals. An inscribed quadrilateral means a quadrilateral that's inside of a circle. So this is called, another way of describing this, there's two different things. The shape inside of another shape is called inscribed. The shape outside of another shape is called circumscribed. So the circle is circumscribed around the triangle, which is inscribed. And when that happens, the vertices of the inscribed polygon has to be on the sides of the circumscribed shape. So this is a quadrilateral inscribed inside of a circle. And what the rule says is that these opposite angles, so A and C, are supplementary. Supplementary, remember, means adds to 180. So B and D would be supplementary. So if they're directly across from each other or opposite of each other, they add up to 180. So if I knew that this one was 100, then this one over here has to be 80 because it has to equal 180. So, because that's what supplementary means. What else do we have? They described why. Oh, and then all the angles inside of a quadrilateral are always 360. So here we have this one. If we have H is 115, what is J? So we can even go over here and use a calculator such as Desmos and do 180, subtract 115, and we get 65. So it is 65 degrees. This one you're going to have to use algebra on, which is totally fine. So I'm going to write these things down. I know that 6x minus 70, the first angle, plus the next one, 76, have to add up to 180 degrees. So I'm going to write this down like this. We're going to combine these like terms right here. So we'd still have 6x, but then negative 70 plus 76 would leave us with just 6 equals 180. So then we're going to just solve by subtracting 6 from both sides so that those will cancel. 6x is equal to 174. Then divide by 6. Divide by 6. And then x, so 6 goes into 17 twice. And then we would have 5 left over. And then 6 goes into 54 9 times. So x would equal 29. Let's look at the question. What is the value of x? Oh, okay, we got it. Equals 29. Oops. Especially if I can click on it. So that was 17.2. And here we go with the checkpoint. So we got 100% on that. Good thing. Is that working? It is. So here we go with the checkpoint. The checkpoint is just asking about inscribed angles and those quadrilaterals. There are 5 questions here we can see because it says 5, or if my picture weren't there, you can see the circles. So we have 2 angles, 2 inscribed angles that are intercepting the same arc. Before I read the problem, I can see that those 2 inscribed angles would have to be equal. So let's just check. So angle BCD measures 34. What is the measure of angle BED? Well, we just said that they'd have to be congruent, so it also has to be 34 because they intercept the same arc. Then we know that those 2 have to add up to 180. So I'm going to write these down again on my board. So I have 2x plus 2x subtract 12 has to equal 180. Switching over to here, sliding it up. We're going to combine the like terms. 2x plus 2x, we know that that equals 4x. Subtract 12 equals 180. I'm going to add 12 to both sides. So I'm left with just 4x is equal to 192. Then we divide both sides by 4. And then x goes into 19 4 times, and then we get 3 left over. 4 goes into 32 8 times. Have you guys seen that division before? It's kind of my favorite thing. You can obviously also use a calculator. So it means that that's 48 degrees. X is 48, but then it wants us to find the measure of P and N. So let's see. P, measure of angle P was 2x. So we would do 2 multiplied by 48. And then the measure of angle N was 2x subtract 12. So we do 2 multiplied by 48 subtract 12. So let me show you what I wrote down. Oh, my picture is in the way. So P is 2 times 48. 2 multiplied by 48 is 96. And then this would be 96 subtract 12, which would be 84. So 96 and 84 is what we want. P is 96, N is 84. There we go. And then we know that those two, because this is a diameter, we know that those two have to add to 90 is the way I said this. So we can do 55, 90 subtract 55. So 90 subtract 50 would be 40, but 5 less than that would be 35. Then we know that those two have to add up to 180. So I can just do 180 subtract 82, and that would leave us with 98 degrees. Right? Right. Okay. And then we have a central angle and we have an arc. So we know that this arc is twice as big as that inscribed angle. And it wants us to find, so it wants to find us to find the inscribed angle. So it's going to be half of 78. So 78 divided by 2 is 39. Especially if I can click on it. All right, there we go. That was 17. Let's just double check that we get 100% because it feels better. Yay!